We are having a hearing this morning on advancing the next generation of aviation technologies. And before I start with my statement, I would just want to make a point to, again, thank the chair of the subcommittee for all her hard work in chairing these series of hearings that we're having, and obviously my colleague, the ranking member, for our discussions. It's our hope that during the recess, members will submit their ideas about things that they would like included in an FAA reauthorization bill. We may not be done with all of our work, but we certainly want to use this period during the recess to surface the ideas that people want to see included and continue that discussion. This morning, the hearing is focused on the United States leadership in sustainable aviation technologies and innovation that will define the next chapter of generation of commercial airplanes, and I believe critical export opportunities for the United States. This is about winning a competitive race for the future. And to meet these new challenges, we must enhance research partnerships, expertise between the FAA and NASA, and FAA standards on certification of novel aviation technologies. We will hear from Associate Administrator Bob Pierce about NASA's work to make this a reality. Today's research will get Americans moving faster, and I'm excited that this year NASA will conduct the first flight of its low-boom supersonic aircraft. Moving America one step closer to supersonic air travel is what the Commerce Committee envisioned when they authorized this program to begin with. NASA's Sustainable Flight Demonstrator Project will disrupt traditional airframe technologies through novel wing design and shape the next generation of single-aisle airline. This has real-world commercial outcomes for America's competitiveness. Single-aisle aircraft are projected to represent 70% of the global airline fleet by 2024. Sustainable aviation is good for the bottom line, enabling airlines to save money and operating costs and maximize fuel efficiencies. The FAA's continuous low-energy emissions and noise clean program will save $36 billion of fuel by 2050, with savings about $90 billion for airlines. These emission cuts are equal to removing 3 million cars from the road between 2020 and 2050. We should triple funding, in my opinion, for clean in its next phase of focusing on zero-emission aircraft innovation. Startups and local governments should have access to federal technology investments. Yesterday, Snohomish County in my state, along with the Washington State University, announced plans for an applied research and development center to produce and store sustainable aviation fuel. U.S.-based projects like these are why it was important in the Inflation Reduction Act to secure funding for developing low-emission aviation technologies known as fast tech and build the infrastructure needed to scale up sustainable aviation fuel SAF. And I'm glad to see that that program is getting launched this year. The FAA's Kevin Walsh will tell us how we can expand its impact in this reauthorization bill. Since the beginning of CLEAN's program, GE has partnered with the FAA to introduce technologies like LEAP, a family of engines powering today's narrow-bodied planes. 3 out of the 4 aircraft departures today across the globe are powered by these engines built by GE in its joint venture, so I'm glad they're here today to talk about that. This kind of success does not go unnoticed in the information age, and we must work harder to keep America's competitive edge. We will hear from Arjan Hegeman about GE's work to develop more efficient open-fan engines, and one day these propulsion systems will power commercial flights around the world. The FAA authorization bill, I believe, can bolster research and development and innovation technologies, but there's also a lot going on in the private sector. Earlier this month, at Aerotech Flight Test Center in Moses Lake, Washington, Universal Hydrogen flew a regional airliner, an 84-foot Dash 8 aircraft equipped with engines powered by hydrogen fuel cells. This was the largest aircraft ever to fly principally on hydrogen power. In January, Zero Avia, with a growing presence in Everett, Washington, flew what was at the time the world's largest retrofitted commercial hydrogen electric aircraft to date. So I welcome both John Gordon from Universal Hydrogen, Val, I'm going to miff to cough, and from Zero Aviation. And I'm proud that these companies, along with Aviation and Magnex, that are in Washington State are continuing to build the next generation of aviation technology. These technologies can provide new access to thousands of local municipal airports on lower fuel costs and maintenance costs. That's why we want to see this develop. So congratulations to both of you for bringing these new products to us in the future, one step closer. Achieving net zero aviation emissions by 2050, a target shared by the industry and the federal government, will require shifts in commercial aviation development and different fuel sources. So this means building aircraft made from lighter weight thermoplastics and composites that are so important, and we want to continue to see leadership on that issue, particularly in the state of Washington. We feel like we must seize on the opportunity with this FAA reauthorization to strengthen America's competitiveness in aerospace. I look forward to hearing from all the witnesses and helping us meet this challenge. I now recognize Ranking Member Cruz for his opening statement.